Okay, pre-calc, now we're going to go ahead and talk about our double angle and half angle formulas that we're going to use. Again, these are options that we get to use in terms of finding and evaluating trig functions that might not be on our unit circle, or in general, these of course come in handy. And if you need a minute, go ahead and pause the video and of course write these down. They are good to have. And if you need to, of course, you can go find that video where they prove them, because that's always a fun one, kind of looking at those. But here you go for your double angle formulas and half angle formulas. Just a quick notes before we get started here, which is that please note, of course, as you can see with sine of 2x and cosine 2x and tangent 2x, they are not just equal to bringing that 2 out front. So very different things in terms of what they're equal to. Just kind of a heads up there. And as you can see here, hey, cosine 2x has 3 equivalencies. It doesn't matter which one that you use. You can use any one. It happens. We'll talk about hey, what might be the best one in that situation so that you'll have a lot of work. And then also make sure that you're looking for the formulas in sine, your half angle for sine and your cosine half angle. Hey, you see that little plus or minus? You don't put both of them in your answer. You pick the one based on the sign of the trig function in the quadrant that you're in, okay? So it's not plus or minus, it's literally plus or minus, depending on what your answer is going to be. All right, so let's go ahead and start here with some examples, and we are going to use the double angle formulas to find equivalencies for the following. All right, well, we have cosine x minus sine x times cosine x plus sine x. That's the difference of squares. That's going to be giving us cosine squared x minus sine squared x. And as we can see up here from our formulas, that is equal to cosine 2x. All right, that was kind of one of those, if you remember, we tried to trick you up with this one in talking about, hey, because we usually have cosine squared x plus sine squared x equals 1, this guy right here equals cosine of 2x. All right, when you have these, I'm actually going to go ahead, we're going to factor out a 3 first, so we now have 2 times sine x times cosine x. And now we can go ahead and look for our formula up here, and we know that this is going to be equal to sine of 2x. So this is equal to 3 times sine of 2x. And one more here with factoring. Let's factor out a 7. 1 minus 2 sine squared x. Looking up here at some formulas that we have to pull from, we can see that we have 1 minus 2 sine squared x is equal to cosine 2x. So we're going to have 7 times cosine of 2x. All right, so you can go ahead, you can of course rearrange things to work for your formulas and kind of simplify them out. All right, let's start here with example 2 and using our half angle formulas to find sine of 22.5 degrees. Well, we can actually rewrite that sine of 22.5 degrees as 45 degrees over 2. Hey, that's kind of nice because sine of 45 degrees is something that we can evaluate. So now that I have this sine of x, or 45 degrees over 2, we're looking up here at our formula here. So we're going to put this 45 degrees over 2. We're going to be in quadrant 1, so we're going to use our plus sign, right? Plus the square root of 1 minus cosine of 45 degrees, because that's going to match in here, all over 2. So that's the formula that we're going to end up using. So we now have the square root, the positive amount. We don't need to go ahead and use that negative because we're in quadrant 1. 1 minus cosine 45 degrees all over 2. And just like our ones before, we just at this point kind of need to be careful of the numbers that we're manipulating here. So we now have the square root of 1 minus square root 2 over 2 all over 2. I'm going to make that 1 a common denominator of 2 over 2, so we now have 2 minus square root 2 all over 2 all over 2. I'm going to go ahead and I'm going to fraction best this by 2, aka multiply both the numerator and the denominator by 2, which is going to give us the square root of 2 minus square root 2 all over 4. Well, that's lovely. We always love when we have a denominator that we can take a perfect square root of. So we now have the square root of 2 minus the square root of 2 all over 2. And you might not be happy with it because I know that that's not a very satisfying answer in terms of something that we've been used to working with, right? But that is our final answer. There's nothing more that you can simplify. You have the square root of 2 minus square root of 2 all over 2 in that scenario. Okay, let's try one more here, which is that given our cosine of theta is equal to negative 3/8 and theta is in quadrant 2, we're going to find A, sine of theta over 2, and B, cosine of 2 theta. So let's go ahead and let's start here with A. We know that sine of theta over 2 is equal to, just kind of like what we did over on the other side, right? 1 minus cosine of theta all over 2. Okay, so now that we have this, we can go ahead and we can replace what we need to. For example here, hey, we know that the cosine of theta is equal to negative 3 over 8, so I'm going to use my substitution rule and replace my cosine of theta. So we now have that this is equal to the square root of 1 minus negative 3 over 8 all over 2. So this is equal to the square root of, that's going to turn into a positive 8 over 8. So we now have 11 over 8 all over 2. We're going to go ahead and think about this as square root of 11 over 8 times 1/2, which is equal to the square root of 11 over 16, which is equal to, final answer here, square root of 11 over 4. So again, a lot of manipulation with these numbers that we just kind of need to be patient and careful with, kind of working on back with those. But the main point about this problem, especially this problem, right, is setting up, hey, if we're looking for this and we're given a cosine value, we want to make sure that we're using that piece of information. Other thing I want to kind of double check, hey, we're in quadrant 2, sine, of course, should be positive there. So just as a heads up on that one. Okay, let's now look at B. So for B, we're looking for cosine. I'm going to actually maybe scoot this over a bit. We're now looking for cosine of 2 theta. So let's just remind yourself what cosine of 2 theta is equal to. If you need to, of course, I have to scroll up, but you can look up on your paper. Now, in this one, right, this is why it's kind of important to choose your formula. Hey, I can figure out what sine is. I can go ahead, I can calculate it if need be. So if you want to, you can do that. But I'm actually going to pick this middle formula here because I have the value of cosine. I don't have to solve for a sine. That seems to be the easiest one to work with here. Okay, so we have that cosine of 2 theta is equal to 2 cosine squared of theta minus 1. All right, now we're going to go ahead and plug in some values here. So we're going to have 2 times negative 3 over 8 squared minus 1. And again, if you're confused as to where I got that piece of information, that's that green thing that we highlighted earlier. All right, so we are going to go ahead, we're going to square that. So we have 2 times 9 over 64 minus 1, which is equal to 9 over 32 minus 1, which if we want to go ahead and kind of show our work here with our improper fraction and turning this 1 into a 32 over 32, 9 minus 32 is negative 23 over 32. So we found what it's equal to. Look at that. A little bit easier for our brains to kind of wrap around that fraction there. So just as a heads up, that's what you're looking for. And of course, making sure that you have these formulas written down, easy to access.